Hey, yo. Let's go over our PDN, shall we? For number 1 and 2, we are looking to create an equivalent fraction given the fact that we have one fraction and the denominator of the next fraction. So remember, when we're going from a smaller fraction to a larger fraction, I want to make sure I'm multiplying on both sides, and I'm going to ask myself, how many times do I roll my 3's, or what do I multiply 3 by to get to 12? What times 3 equals 12? And if I roll my 3's, I know that it's 3, 6, 9, 12. It's 4 times. So I'm going to multiply both sides by 4 over 4. 3 times 4 equals 12. 2 times 4, 2, 4, 6, 8 equals 8. So 2/3 is equivalent to 8/12. When I'm moving from 6 to 3 now, in my fraction 6/8, I know I'm going to be dividing on both sides. So I need to ask myself, how many times can I roll my 3's to get to 6? What do I need to divide 6 by to equal 3? Or what times 3 equals 6? I'm going to ask myself, what times 3 equals 6? So I'm going to roll my 3's. 3, 6. Well, 2 times 3 equals 6. So I know if I make sure I divide by 2 on both sides, I will get 6 divided by 2 equals 3. So now 8 divided by 2, what times 2 equals 8? 2, 4, 6, 8. 4. So 8 divided by 2 equals 4. And 3/4 is equivalent to 6/8. For question number 3, it asked us to divide 95 divided by 3. And we were asked whether or not how many games Turnell could play at Dave & Buster's if each game cost $3. And he had $95 to spend at Dave & Buster's. Turnell, nice job having $95. So I'm going to first multiply in my largest or divide in my largest place value using DMSB. First step is to divide, so I roll my 3's into 9. 3, 6, 9. 9 divided by 3 equals 3. Put a check next to divide. I multiply 3 times 3. That equals 9. Now I need to subtract. 9 minus 9 equals 0. And then I bring it on down and bring it on back. I bring down that 5. I put a check. Now I'm going to see how many times can 3 go into 5. So I'm going to roll my 3's until I land on 5 or get to a number that's bigger than 5. 3, 6. 6 is already bigger than 5, so I need to skirt. And I actually need to go back 1. 3 can fit into 5 one time. So I put a 1 up here, put a check. And now I'm going to go 3 times 1. That equals 3. And now I'm going to subtract 5 minus 3, which equals 2. And then I'm going to bring it on down and bring it on back. But since I have nothing to bring down, I am done. And since I can't, 3 is bigger than 2, I actually have this 2 left over as a remainder. So I'm going to write in my quotient line R2. What that means in my question is, using $95, Turnell can play 31 games, and then he has $2 left over. So I would write 31 remainder 2. Now, Turnell can't go to Dave & Buster's and play a $3 game with $2. So we're going to have to leave this quotient the same instead of adding 1 on. So I'm going to write Turnell can play 31 games at Dave & Buster's. Put a period at the end of my sentence. And now we're ready for some board equals paper. Today, what we're going to be doing is we're going to be comparing fractions with like numerators. Just like yesterday, where we compared and ordered fractions up to 5 fractions, we're going to do that same thing, but instead of having the fractions with the same denominator, they're going to have the same numerator. When fractions have the same numerator, the larger the denominator, the smaller the fraction. This is kind of like the opposite of yesterday. Yesterday, the larger the numerator, the larger the fraction. When the numerators are the same, it's kind of the opposite. The larger the denominator, the smaller the fraction. And we'll see why in a second. Let's do this example first. First thing we always do when we read a problem like this, order the fractions from greatest to least. We're going to make sure that or from least to greatest, excuse me, we're going to make sure we read the problem carefully, like I just didn't. Yikes. And now we're going to actually reread that again. Order the fractions from least to greatest. Gator eats the grater. I'm going to first line up my inequality symbols and make sure that I have every inequality symbol of the gator eating the grater. Bam. 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 And bam. So when I read this, it'll be blank blank is less than, blank blank is less than. So I will put my smallest fraction first. Now I'm going to go down to my bar models and see which fraction is the smallest. I have 3/5, 3/9, 3/12, 3/4, and 3/10. I'm going to first use these bar models to fill in 3, 1/3, or 1/5, 2/5, 3/5, 1/9, 2/9, 3/9, 1/12, 2/12, 3/12, 1/4, 2/4, 3/4, 1/10, 2/10, 3/10. Now I'm going to look to see what is my smallest fraction here. Which fraction takes up the least amount of the whole? Well, when I look at all of these bar models, I see that 3/12 takes up the least amount of my whole. And that makes sense because it has the largest denominator. It's split up into the most parts, so each part is worth less, or each part is smaller. So my smallest fraction is 3/12. My next smallest fraction is 3/10. If you notice, 3/10 takes up the least amount of space after 3/12. So I'm going to put a 3/10 right here. Then it's going to be 3/9. Then 3/5. And then 3/4. The big key here is that it's sort of like the opposite of when we compare a fraction with the same denominator. If I look here, the fraction with the largest denominator, when all the numerators are the same, is the smallest. So if I read this, it goes 3/12 is less than 3/10, is less than 3/9, is less than 3/5, is less than 3/4. When the numerators are the same, all of these numerators are the same, the larger the denominator, the smaller the fraction.